You've now taken some time to study arithmetic sequences, and then we've gone into slope-intercept form, and now we're going to move into geometric sequences. And so today I want to take some time to introduce this to you. In this video, I want to do problems with you. So make sure that you do have this practice, 10-7 practice geometric sequence sheet in front of you. As we go through the video, pause anytime you need to. But I do want you to work with me on this side of the worksheet. The back side of the worksheet, the 10-7 skills practice, you will do that on your own. But I will be doing some problems with you from the front side of this sheet on geometric sequences. So first of all, let me define for you exactly what a geometric sequence is. A geometric sequence is exactly this. It is a sequence where the terms are found by multiplying by the same number. The number you multiply by is called the common ratio. Okay, so with arithmetic, we were always adding them. With geometric sequences, you are always multiplying. The number we multiply by is called the common ratio. And often the common ratio is used, and it's called the letter R. You'll see that here in a little bit. So now, just to practice determining whether a sequence is geometric, let's look here, turn the sheet to the practice side, and let's look at number 1. The sequence here is 3, 12, 48, 192. Notice how it's going up fairly quickly, so there is a chance this could be a geometric sequence. If I try to find the difference between 3 and 12, 12 minus 3 is 9. So 9, if I try to use the 9, 12 plus 9, that is 21. It isn't 48. So this is not arithmetic. So let's see if it's geometric. Can I multiply 3 times something to get 12? Yeah, the answer to that is yes. I can multiply by 4. I can say this is timesing by 4 here. If I do 12 times 4, do I get 48? If you're not sure of that, take a calculator from the front of the room, and I'll take mine here, 12 times 4, and it does equal 48. All right, well, let's try 48 times 4. I'll take my 48, it's already in my calculator, so I'm going to press times 4. It equals 192. So this one, yes, it is multiplying by times 4 each time, so I can say that yes, this is geometric. Let's look at number 2. The sequence is 2, 17, 32, 47. Off the top of my head, I don't know of a number that I can multiply 2 by to get to 17, but I do know that 2 plus 15 is 17. What happens then if I take 17 plus 15? I get 32. Looks like this one might be an adding one, so that's not what we're after. We want to multiply. What if I do 32, leave that in my calculator, plus 15? 47. So this is actually an arithmetic one because it's always adding by 15. So our answer on this one is no. This is not geometric because it's doing a plus 15. First one was because I was timesing by 4. This one is not because it's adding the same amount every time. Geometric is always multiplying. Let's look at number 3. Well, the numbers are going down. So I go from negative 200, negative 135, negative 70, negative 5. So it's actually not that I'm going down, but my numbers here looks like it might be dividing. I'm not sure. Well, let's see. If you go from negative 200 to negative 135, is there something I can multiply by? If I don't know it off the top of my head, let's do this. We're going to take, and I want you to take your calculator, and we're going to take the second number, negative 135. So we'll take our calculator, and we're going to type in a negative 135. We're going to divide that by the first number. The first number was multiplied by something to get the second number. So we got to work it backwards. So we'll take the first number divided by, take the second number divided by the first number. So I'm going to go divided by, and I'm going to type in 200 and make it negative, and I'm going to see what my answer is. It says 0.675. All right, so maybe this was multiplied by 0.675. 0.675. Let's now take our calculator again and let's clear it out and let's type in negative 135 and we'll go times, and I got 0.675, so 0.675 equals negative 91.125. That doesn't work either. So I wonder, is this actually maybe adding something in? What happens if I take negative 200? And actually I wouldn't have to go any further because here I can't multiply this by the first two terms by the same amount. So it doesn't matter if it adds or not. If I'm looking for geometric, I have to be able to multiply by the same number. This doesn't work. So the answer to this one is no, that is not correct. It does not work. It only works between the first two terms, and I'd have a different number to multiply by for the next two terms. So no, this is not geometric. Let's look at number 4. It's kind of the same style. It starts with a big negative number and starts to go down. It goes from negative 220 to negative 110 to negative 55. Okay, so now I'm heading back towards 0, aren't I? So let's see here. If I go from negative 220 to negative 110, is there something I could multiply by to get there? There might be. Let's try the procedure. Let's take the first term, or I'm sorry, the second term, clear my calculator, and I'm going to type in 110, and it's a negative number, so I'm going to put my negative sign in, and I'm going to divide by the first term, divided by, and my first term is negative 220, and I need my negative sign. So negative 110 divided by negative 220 equals 0.5. So the question then is, am I multiplying by a half each time? Am I multiplying by 0.5? So I'm going to make a note over here. Am I multiplying by 0.5? All right, so we know that if we take negative 220, and if I multiply that times 0.5, I get a negative 110. So now I want to take negative 110 and I want to multiply again. And I'm going to take that times 0.5. And let's see what I get for an answer. Negative 55. Aha. Maybe I found the correct thing. Let's try it to see if we can get the last term. We want to get a negative 27.5. So since negative 55 is in my calculator already, I'm going to push times 0.5 equals negative 27.5. So yes, this one is geometric. It is always multiplying by 0.5. So this is yes. Lastly, let's take a look here. Number 5 has a positive to a negative to a negative. I'm sorry, negative to a positive, and then positive to a negative, and then now we have negative signs are alternating. Notice that the first term is negative, second term positive, third term negative, fourth term positive. When you see a sequence like this, there's a real good chance you are multiplying by a negative number. When you start seeing the negative signs alternating, you're probably multiplying by a negative number. I don't know this off the top of my head, so I'm going to take my calculator again and I'm going to clear it out. And I'm going to take the second term, 248. I'm going to divide it by the first term of negative 992. So 248 divided by negative 992. And let's see what we get here. A negative 0.25. So that's suggesting that I am multiplying by a negative 0.25. So let's put that over here times negative 0.25. And let's test this and see if it works. So I'm going to now take my calculator again, and I want to take negative 992, and I want to take it times negative 0.25, and I'm going to see what I get for an answer. Positive 248. It's positive 248. It's already in my calculator. Just push times. And now let's multiply by a negative 2.5 or 0.25 again. And I got to make sure I have that as a negative. It equals negative 62. There's my answer. So now I have, let's see if we can get 15.5. So I'll take this times 0.25, make it negative, equals, whoops, I multiplied that wrong, didn't I? Let me clear my calculator again. So we have to have negative 62, negative, times 0.25, negative. I believe I must have actually typed 25. All right, my apologies for that. 15.5. So yes, this is geometric. So again, when you're multiplying, trying to determine, you want to take a look. Am I multiplying by the same amount? That's a geometric sequence. So we have 1, 4, and 5 that, yes, they were geometric sequences. All right, determining the next terms in each geometric sequence. What they're telling you here on problems like this is these are geometric. You will be multiplying by some amount. You'll be multiplying by something that's a decimal or a fraction, or you're going to be multiplying by an integer. So let's take a look at number 7. Negative 4 to negative 20. I know there's a relationship between 4 and 20, and I know that 4 times 5 is 20. So if I take negative 4 and I multiply that times 5, do I get negative 20? Yes, I do. If I take negative 20 times negative 5, I'm sorry, times 5, do I get negative 100? Yes, I do. All right, so I want the next three terms. So I'm multiplying here by 5. So we are timesing by 5. So I want the next three terms. So I'm going to take negative 500, clear my calculator. I want to type in negative 500. I want to take it times 5. I get a negative 2,500. So my first term that I'm writing down here that I have to find is negative 2,500. Now I need to multiply by 5 again. So I'll take that answer times a 5, and I get, oh, I'm getting bigger numbers, negative 12,500. And I need to take this times 5 again, because it says find three terms. So times 5, probably going to get a large number, negative 62,500. So that's number 7. So I'm finding the next three terms. Figure out what you have to multiply by, and then multiply it three times to find each of those three terms, and you list them out. Let's take a look now at number 8. Okay, so in number 8 now I have a positive, followed by a negative, followed by a positive, followed by a negative, alternating. That means, just like when we had up in problem 5, we're probably multiplying by a negative number here. So 7 times what is 21? I know 7 times 3 is 21, so that, since it's one's positive and the next one's negative, I am probably multiplying by negative 3. So to test that, let's clear our calculator. Let's take negative 21, make it negative, and I'm going to take that times negative 3. And I get positive 63. So we are multiplying here by negative 3. So to find the next three terms, I now am going to clear my calculator. I'm going to type in a negative 189, and I'm going to take that times negative 3. And I get 567. And now I want to take 567 on my calculator, and I'm just going to push times negative 3 again. And I get a negative 1,701. And I have to find a third term. So one last time, times negative 3. And I get 5,103. So I want to write that down, 5,103. Okay, so you have a couple of examples from this side here that you can refer to. Moving on. Let's take a look here at 13, 14, and 15. Let's take a look. Find the nth term of each geometric sequence. So what they want us to do, the A1 stands for the first term of the sequence. So that if you look at number 11, if I was to talk about number 11, A1 will be the 5. That's the first number in the list. N tells you how many terms they want you, what term number they want you to find. That's going to be the fifth term. R is common ratio. R tells you what to multiply by. R tells you what to multiply by. So I want to type that out here for you, just to remind you, is that R so here's what we got to do. So if I'm looking at number 13, okay, A1 is 6. 6. R tells me what to multiply by, times 3. So I'm going to go times 3. 6 times 3, I know that to be 18. I know that one off the top of my head. How many terms do I have to find? I have to find the fifth term. So that means I have to keep going. I only have 2 terms. So I'm going to multiply by 3 again. Take my calculator. I don't know that one off the top of my head, so I'm going to clear that, and I'm going to go 18 times 3. That equals 54. So I have 54. Well, I only have 3 terms. Got to do it again. Times 3. Take my calculator. 54 times 3 equals 162. I have 4 terms, but I need 5. So I'm going to take that. Again, I need my calculator. I got 162, and I want to take that times 3. And that is times 3. Oops, I forgot the number. It's 400 something. 486. 486. So when you are doing these types of problems on the back side, we're going to take the first, A1 is your first number, write it down. N tells me how many numbers I have to find. I got to get out to the fifth number. I want to find the fifth term. So the answer to number 13, the fifth term, is 486. R, common ratio, tells me what to multiply by. And notice I multiplied by 3 here until I got to the fifth term. So if I'm asked to multiply then on number 14, I would start with -9. I'm going to multiply by 2, and I have to define it and go until I find the sixth term. So on the back side of the sheet, that's what you'll be doing there. All right, so you can feel free to turn this over and work on the back side. If you have any questions, please ask me for help.